So at this point, I think there's no doubt in anybody's mind that AI is changing science as well as the medical industry forever. And we actually had a very, kind commenter who shared a really good story about AI doing exactly what I said in the last video that AI was of the article we read, where AI is able to assess certain health problems before they actually occur. And one of our commenters actually said that actually happened. So right now, AI is changing lives. It could save your life. But anyway, we have this article here, and it's titled Assessing GPT-4 for Cell Type Annotation in Single Cell RNA Sequence Analysis. It's getting very, very deep, very fast, folks. Let's read this little tidbit here. It says abstract. Here we demonstrate that the large language model, GPT-4, can accurately annotate cell types using marker gene information in single cell RNA sequencing analysis. When evaluated across hundreds of tissue and cell types, GPT-4 generates cell type annotations exhibiting strong concordance with manual annotations. It says this capability can considerably reduce the effort and expertise required for cell type annotation. Additionally, we have developed an R software package, GPTCelltype, for GPT-4's automated and cell type annotation. Wow. Then they have the main section here. It says cell type annotation is a fundamental step in single cell RNA sequencing analysis. This process is often laborious and time consuming, requiring a human expert to compare genes highly expressed in each cell cluster with canonical cell type marker genes. Although automated cell type annotation methods have been developed, manual annotation using marker genes remains widely used. Generative pre-trained transformers, GPT, including GPT 3.5 as well as GPT-4, are large language models designed for language and understanding and generation. Recent studies have demonstrated their effectiveness in biomedical contexts. In this brief communication, we hypothesize that GPT-4 can accurately annotate cell types, transitioning the annotation process from manual to a semi or fully automated procedure. GPT-4 offers cost efficiency. Well, we know about all of that. But what's happening here is absolutely amazing. The vast training data of GPT-4 enables broader applications across various tissues and cell types, and its chatbot nature allows for user-driven annotation refinement. It says, we systematically assessed GPT-4's cell type annotation performance across 10 data sets covering 5 species and hundreds of tissue and cell types, and including both normal and cancer samples. GPT-4 was queried using GPTCelltype, a software tool we developed. This is by methods. For competing methods, we evaluated GPT 3.5, a prior version of GPT-4, and Cell Marker 2.0, single R, and SC type, which are automatic cell type annotation methods that provide references applicable to a large number of tissues. Cell type annotations by GPT-4 or competing methods were evaluated based on the agreement with manual annotations provided by the original studies. The degree of agreement was measured using a numeric score. Supplementary Table 3 presents an example of evaluating GPT-4 cell type annotations in human prostate tissue, and details of all cell type annotations and their evaluation results are included in Supplementary Table 4. Listen, this is an amazing article. You can find it on nature.com. All right, nature.com. Wow. The future is wildly different, but listen, I feel like a lot of people might be saved with these types of things. They might be able to catch something early. Heck, I'm not sure if this has already occurred or not, but they may be able to come up with quite a few, maybe cures. Do you think that, maybe some of these AIs could come up with some cures for things, or I don't know, or better methods at dealing with certain things? I think it's possible. So now let's move on. We have one more article. Yeah, it's not over yet. There's always something happening in AI and robotics. And we'll get back to the robotics in a few, probably next video. But this article here is titled, oh, no. Here we have some robotics right here. Autonomous robots help farmers prepare for world's largest tulip bloom. Listen, right now, I read an article probably about a week ago. They're having problems replacing farmers. The average age is very high, and yet they don't have a lot of new people coming into the farming industry. So to have some robots, to have a little AI, this is an AI-enabled robotics platform here, helping out, that's a good thing because the world needs farms, at least from what I know. The world needs farms to continue forward so things can run smoothly. So this begins here. It says, starting in early March, dozens of large, futuristic-looking white machines started slowly trolling through farmland in the Netherlands. At first glance, the machines looked like a cross between a tractor and a World War I era track-based tank, albeit with a distinctly shiny sci-fi shimmer. The machines are actually fully autonomous AI-enabled agriculture robots tasked with spotting and eliminating diseased tulip bulbs ahead of the country's iconic and financially significant spring tulip bloom. Wait a minute. Sorry about that. My mind was going elsewhere because I remember seeing a video the other day. It's a little bit creepy when synchronicities occur. I saw a video, I believe it may have been on TikTok, and there were AI-enabled machines going through a farm, and I don't think it was tulips. It was maybe some kind of vegetable or something like that, but it was using lasers. I don't know that that's what this is. It was using lasers to remove weeds. That's what they showed. They showed them spotting out and removing weeds with laser technology. But anyway, let's continue on here. It says the Dutch-made robot is just one of many new autonomous tools quickly making their way onto farms and ranches around the world. The tulip spotting robot, designed by the Netherlands-based company H2L Robotics, is officially called, quote, Selector 180, unquote. Weighing in at roughly 2,600 pounds, the Selector uses GPS coordinates to autonomously drive through tulip fields and onboard cameras to take thousands of photos. An AI model then combs through these images, looking for signs of potentially diseased bulbs, which often are identifiable by distinctive red stripes on the bulb's leaves. Wow. So now AI has now aided the farming industry. We'll see how what's interesting is AI is advancing so quickly. How fast do you believe robotics is keeping up with how fast AI is advancing? See, I'm rapidly becoming more familiar with AI, right? I started out, I was pretty much new. Now I know a great deal after all of this time covering AI. I know a great deal now. But robotics is still new to me. So I'm not sure how fast they're moving with robotics. Can it keep up with the rapid pace that AI is moving? I don't know. I guess we'll see. So now that you have that information, everybody, what are you going to do with it? I know what I'm going to do with it. And until next time, take care.